I understand that there's a lot of work being done these days in materials research, putting together materials that have different or maybe better properties. Do you use any special materials in this kind of house?
Absolutely. We first started looking at sustainability as a function of materials. We were looking at roofing materials, exterior materials, flooring materials, and things.
When you say sustainability, that means that you're not impacting the environment, you're not using up a precious resource that we're going to run out of?
That, and that we're not having to replace or paint the house every year, or replace, you know, some of the materials because they wear out or they have a short
so it's a low maintenance?
Yeah, the whole idea of easily maintained house. The other thing that we added during the design process, there were a lot of students in the lab from architecture, film, music, art, engineering, business school, library. We had as many students involved as possible, as well as faculty. And there was some late night sessions, and one night we were sitting around talking, and we realized that there's a short story from 1959 about a house that's built, and you know, the drapes go up in the morning and the coffee pot starts percolating, and you're about 3/4 of the way through the story and you realize, wait a minute, there's no people in this story. And we realize that the sustainability wasn't about the materials. All of the things that we do, whether it's sustainability, whether it's low energy use, is all about human comfort. That's the key, is to keep the human factor in the design of the house.
So you're saying technology is not that useful unless people are actually deriving some benefit from it?
Well, technology is very useful to attain that kind of benefit so that the humans are living in an environment that's comfortable and is sustainable. It's sustaining the human being as opposed to just the material that's in the house.
I think we have another slide. Can we see the next slide? Okay, so this looks like it's maybe in the basement, if the house has a basement.
It is.
And this looks like maybe the plumbing and the electrical conduits.
Yeah, this was interesting because at the very beginning of this project, one of the mechanical engineers said, we can make this thing look like the mechanical room in the Yellow Submarine. And everyone laughed. And then it was interesting to see the subcontractors. This is almost like jewelry in there. You go in there and it's beautiful. We take people in the mechanical room and they want things exposed, all the connections, all the brass fittings, all of the welding. This is just a work of art. But at the same time, it is a work of complexity, and it also is showing how the systems start to work together so that we don't lose heat. We're capturing all the heat. We're not just exhausting it. And we're not even wasting the hot water that is going through the pipes as far as that heat.
Now this is on the grid, right? I mean, it's not generating its own energy. It's plugged into the electrical grid. It gets its water from the same place that everybody else gets it.
It is currently, but it's designed so that it could be in the future. We have the potential for adding both photovoltaic and hot water solar systems to it.
Okay. And I understand that this house won an award for Best House given by the U.S. Green Council.
Yeah, we were very pleased.
Green Energy Council, and we have a picture of the award. There's the award right there. There's your name sort of in the lower left.
Mm-hmm. And it's a real team effort. You can see there's a lot of people involved in this. The contractor, the structural engineer, the homeowner, the university, and the major corporate sponsor. So that was the key. This is a lot of people working together successfully to create a project that is award-winning.
Now, is this an experimental demonstration house, or is there somebody actually living there now?
Right now, it is being run as a laboratory. It's like a living laboratory. Later this year, the family will move into it, and it's actually a 3-generation family. So that's part of the design of the house, is for multi-generational living, and also to test, to make sure that we've designed a house that normal people can operate, not just the mechanical engineers who designed it and installed the equipment. So that'll be part of what we'll be doing, is adjusting when the family moves in to learning how successful they are in being able to control the environment.
How would the cost of a house like this compare with a regular house? Since this is a one-of-a-kind house now, it's obviously a lot more expensive, but if it goes into large production, would it economically be better than a traditional house? Would you save money by buying this kind of house?
Well, the goal of this house is not to be a prototype that would be replicated over and over again. The goal of this house, we have 11 different mechanical systems in this house that we're going to test head to head. And we will see for our region, which was the sort of the Front Range, Northern Rockies region, because every region on Earth has its own sort of microclimate, whether it's a lot of cold, a lot of heat, a lot of humidity. Montana is very dry, so the solution for Montana will be adjusted when it goes to other places. And as we learn more about, no one has done what we did, which is put so many mechanical systems in them that in the same time, in the same place, you can test them head to head. A against B, A against C, A against D, and see what kind of results that we get. One of the magazines called Our House will be the most monitored house in North America. And we hope that the value to everyone who's building a house is the information that we're gathering and what we learn from testing this house as a laboratory.
When you say it's monitored, that sounds like a developing trend, what people are calling the Internet of Everything, where you can put some kind of sensor on just about any kind of object, and that sensor can detect things and report them instantly to the Internet, so you can see at a glance temperature, any motion of anything, movement of fluids through pipes.
Absolutely, and we do that in this house, and what you've just identified is really one of the most exciting aspects of the future of architecture right now, because as we become able to design our buildings and design our environments to coordinate with this sensor information, for example, in the old days you'd drive into your driveway and take your garage door opener and push a button and your garage door would open. In the future, we'll be able to design a house that the garage knows you've just driven in the driveway and your car knows, and if you want to put it in the garage and you opt into these kinds of opportunities, that the building knows who you are. It's not just this static big object sitting there. And applied to commercial buildings, imagine you and I have an appointment at 3 o'clock in a corporate headquarters. When we walk in the building could know who we were if we opt into that kind of sensor communication. It could say that the meeting's been moved to another room if it has been. In other words, the building can help us accomplish the things that we're trying to do. Whether it's a house or whether it is a commercial building, we're going to be able to build as architects buildings and environments that really support human activities and human interaction.
Is there a possibility of loss of privacy with something like that? If sensors are following you around wherever you go all the time and reporting everything you're doing?
That is a big concern, and it's real and it's serious, so I don't want to say no, there's no concern. But as part of the opt-in, we all have to learn what we want to participate in and what we don't. I think where we're going to see significant buy-in from most people is in the medical and health fields, where if someone has a heart rate that needs to be monitored or an oxygen level that needs to be monitored, that may be okay that we're transmitting that information and being monitored. Whereas some of the other security that people are concerned about, they don't have to opt into those kinds of things. And I think the other thing is, I think we should take control of this technology and figure out what we want to use it for, and not wait and find out what other people are using it for necessarily.
Now, you've also been involved in a lot of other activities pertaining to architecture. You've been involved in something called the AEC Hackathon.
Yes.
What's that all about?
Well, if you look at the age of digital watches, computers, the telephone, airplanes, they're outdistanced by the building industry by 5,000 or 10,000 years. It's been around a really long time, and it's had the ability to develop a lot of mom and pop organizations. It's not like the big five that used to be in automotive companies or the few airlines manufacturers that we have. In the building industry, there's thousands and thousands of different small manufacturers. So it's a tougher industry to sort of improve. It takes a long time to improve it, and you have incredible cost overruns. So we think that by looking at and exploring with hackers, you know, young people that aren't used to not being able to do this or not be able to do that because it's not been done that way for so long, that we'll actually find some really interesting and exciting ways to improve the industry in a shorter period of time than if we just sort of wait for the large interests to sort of catch on to this technology and how it could be applied to the building industry.
So when you say AEC Hackathon, first of all, what does AEC stand for?
Thank you for asking that. It's architecture, engineering, construction. And that is sort of the three categories that architects, engineers, and contractors are aware of. Of course, there's real estate, financing, and facilities management that bracket that as well. So it's a big industry from start to finish when you try to get information flowing from one end to the other.